Const is another way to declare a variable. It has all the features of let, but it's also read only. You cannot reassign a const. So let's look at this program here. We're running this print many times, and it's going to log out this sentence, and the sentence is up here, var sentence, it's declared, and then we reassign it here. So first we declare the sentence to be the string is cool, then it's reassigned to be the string is amazing. So if we run that, it should work. It prints free codecamp is amazing many times. But if we change this to const, let's see what happens. Now I'll run this and we get an error. Sentence is read only. If you declare a variable with the const keyword, you cannot reassign it afterwards. This can be very helpful to prevent you from accidentally making mistakes later. If you know for sure that you never want to reassign a variable, always use const so you don't accidentally reassign it when you don't mean to. Another thing is when you're using const, it's very common to use all capital letters. So like this, sentence, like that. And that's another way to remember that it's a constant. So if I rename this here, I'm also going to have to repeat it here. And while we're at it, we're going to change this to let, because for the most part, you should only use const or let, but there are certain circumstances where you would use var. And also in some other videos in this course, I'll be using var, but in your own code, you should mainly use const and let. Let's reload this to see what happens. And it worked. Free codecamp is cool many times. We can no longer say that free codecamp is awesome, even though we know it actually is. While you cannot reassign a variable declared with const, you can mutate an array. So look at this example that's not going to work. First, we declare the variable s and we assign it to an array. We declare it with const. And now we're going to reassign the variable s here. But if we do that, we're going to get the error. S is read only. However, we can update the array using bracket notation. So I'll just comment that out. And using bracket notation, I'll do index 0. I'll assign that to 2. Index 1, I'll assign that to 5. And then index 2, I'll assign that to 7. And just like that, it is going to reassign the array. So if I just do a console.log here, console.log, and put the array in there, we should see the new array here, 257. As seen previously, a const declaration alone doesn't really protect your data from mutation. If you have an object or an array, you can still mutate it even if it's declared with const. There is something called object.freeze that will prevent data mutation. So let me talk to you about object.freeze. First of all, let's understand this function here. We're using this function to demonstrate object.freeze. So it's going to create this constant, math constant, with a pi in it. This is an object. And right now, this can still be changed. So if we look down here, this is a try-catch block. We'll talk about try-catch blocks in more detail later. But for now, you just have to know that it's going to try what's in the first part of the block. And if there's an error, then it's going to go into the catch part and it's going to log it out. So right now, we're going to try to change mathconstants.pi to 99. And if you can see right here, we're going to return the math.constants.pi. And down here, we are putting it into a variable called pi. So if we run this, you'll see that we console.log pi and it's 99. But wait a second, we don't want pi to change because we know that pi never changes. That's why we're going to use object.freeze. So I'll put it right here. I'm going to do object.freeze. And then in parentheses, I'll put the object, which is math constants. Now I've frozen math constants. So when it tries to change math constants.py here, it's not going to work, and it's going to go into this catch block, and it's going to log out the error or the exception. So let me run that, and you'll see type error cannot assign to read-only property of pi of object. So we had an error, and we can see here that pi stays the same at 3.14. So whenever you have an object and you don't want any of the items in the object to change, use object.freeze. This function here is called an anonymous function. It doesn't have a name. It is assigned to this variable magic, but there's no word right before the function keyword to assign the name to the function. Whenever you have an anonymous function, you can convert it into an arrow function. That makes it a little quicker to write. So instead of the word function, I'm going to take that out completely and then put an arrow here. So this is the same thing, except it's just a little quicker to write, but we can shorten this even more. If we're just returning one value here, we don't even need the return keyword, and we don't need the curly braces. So I can delete all this, and I can delete all this here. And now this is the full function from before, but it's just really shortened up. And to make this even nicer, we're not going to use var. I'm going to change this to const. Just like in a normal function, you can pass arguments to arrow functions. So let me show you how to convert this function into an arrow function. So it's a normal function now, and it has two arguments, and then it's going to concatenate the two arrays passed in. So first, we'll take off the function keyword. We're going to leave these parentheses with the parameters. Now I'll put the arrow. Since all we're doing is returning this, we don't even need the return keyword, and we don't need the curly braces. So I'll take that off. We'll take this off. And now we've done this. I just converted that function into an arrow function, and it has these two parameters. So we just have the parameters in parentheses, we have the arrow, and then we have what's being returned right after the arrow. So if I run that, you'll see that we concatenate the two arrays that are passed in this example. And then for good measure, we'll change this to const. Arrow functions work really well with higher order functions such as map, filter, and reduce. I'll go into more detail at a different time about map, filter, and reduce, but the main thing to know is that they take functions as arguments for processing collections of data. Whenever one function takes another function as an argument, that's a good time for an arrow function. So what we're going to do here is we're going to update this function right here. We wanted to compute the square of only the positive integers in the array. So it's pass in this array, which is this, and we want to filter out everything that's not a positive integer. So I'm going to use the filter and map functions to do that. But the main thing I want you to look at is the arrow functions that I'm passing into filter and map. This line is going to be a lot more succinct because of the arrow functions. So we have the squared integers is going to be the r, and we're going to filter this. So dot filter. Now, again, I'm not really going to explain in detail what the filter function does, but that will be something for another time. Just look at this arrow function. We're going to create this arrow function by starting it just like this. Now, before I showed you that you pass in arguments in parentheses for an arrow function. But if you only have a single argument like this, the number argument, you don't need parentheses around the argument. You can just put the argument and then the arrow. So this is the beginning of the arrow function, and then we'll see what's returned from the arrow function. First, we want to filter this array so we only have numbers that are integers and numbers that are more than 0. So we'll do number.is integer, and then we will pass in the number, and number is more than 0. So let me complete the parentheses here. Now, the result of this filter command will be an array with all the numbers that are more than 0 and also integers. So that would be 4, 42, and 6. But after we get that new array, we want to get the square of each number in that array. So that's where we're going to use the map function. Now, the map function takes a function as its argument. But instead of writing a full function out, we can use an arrow function. So we're going to pass in x to the function, and then there's going to be an arrow function. Now, x just means every element from the array that's being passed to it. So remember, the map is getting the array 4, 42, 6. X means for every element in the array, this is what we're going to do to it. X times X, because it's going to be squared. Again, the main point of this lesson is not to understand the filter and map functions, but to see that we can put an arrow function, we can pass in an arrow function, and it makes it so we can fit everything really succinctly on one line. So let's reload this and see if it works. Now we have 16, 1,764, and 36. In order to create more flexible functions, you can use default parameters. The default parameter kicks in when the argument is not specified or is undefined. So for instance, with this increment function, we want to change it. We want to change the increment function so you can pass in two arguments, the 5 and 2, to increment by 2, or you can just pass in the one argument, the 5, if you want to increment by 1. So here are the numbers we're passing in, a number and a value. So we just have to put value equals 1. So now, if a value isn't passed in, it will be set to 1 automatically. But if it is passed in, it will be set to whatever's passed in. So if we run this, we can look on the console. We have 7 for this first one and 6 for the second. The rest operator allows you to create a function that takes a variable number of arguments. The rest operator is 3 dots. So we have this function here, and it's taking 3 arguments, x, y, and z, and it's summing them. So at first, it's converting these x, y, z into an array called args, and then it's reducing them. So it's summing them all up here, and then returning the result. So right now, if we just run this, it's going to log 6, because 1 plus 2 plus 3 is 6. But we can change this to use the rest operator. So we're still going to pass in 1, 2, 3, but where it's accepted here, where we have the arguments here, x, y, z, I'm just going to put dot, dot, dot. That's the rest operator, just dot, 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 and I'm going to put args. So with this rest operator, dot, 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 it will convert everything that's passed in into one array, and the array is called args. So now we don't need this anymore, and it should work the same. If we run this, we'll get 6. But we can also now add any number of numbers. So I'll put a 4 on the end, and 10. It's going to add those numbers together. So before we could only pass in 3 arguments, and now we can have any number of arguments. The spread operator looks just like the rest operator, 3 dots, but it expands an already existing array, or it spreads out an array. So it takes an array and spreads it out into its individual parts. So here we have an array with some months, and the spread operator can spread this array, this R1, into the individual months instead of the actual array here. You can only use it in an argument to a function or in an array literal. So let's look at this. So right now, we're setting array 2 to equal array 1. In this example, we're not actually copying it, because if we change array 1, if we set the index of array 1 to potato and we log array 2, you'll see that index 0 is potato, even though we're logging array 2. and we only changed array 1 because these are equal. Array 2 and array 1 are the same. But what if we want array 2 to be a copy of array 1? We can use the spread operator. Now, we can't just use the spread operator like this. That's not going to work. But if we put this inside brackets, which is an array, it will spread out the contents of array 1 into this new array. So we're not making array 2 equal array 1. We are making array 2 equal all of the contents of array 1, so they'll be different. So if we run this again, you'll see that it says January for the first element in the array instead of potato. The next few lessons will be about destructuring assignment. This is a special syntax for neatly assigning values taken directly from an object to a variable. So look at this object here. We have this object with 3 elements. We have the x, y, and z with their values, and it's all in the voxel variable. So if we wanted to take each individual element in this object and assign it to its own variable, this is the old way of doing it. So you could do voxel.x to stores x, voxel.y to stores y, voxel.z to stores z. Now with destructuring, there's a simpler and quicker way to assign variables for each element in an object. So here's the destructuring syntax right here. This time, we are creating variables a, b, and c and assigning them to the values from the object x, y, and z. We can see we put in curly braces here, and we just say it equals the object. It equals voxel. You can read it like this. Get the field of x and copy into the value a. So get the field of x from the object, copy into the value a. Get the field of y from the object, copy into the value b. Get the field of z, copy it into the value c. So this is just a quicker way of assigning things from an object into variables. Now we're going to use destructuring to obtain the average temperature for tomorrow from the input object average temperatures. So we have average temperatures. It has today and tomorrow's temperatures. And then the average temperature is inputted into this function here. So I'm going to change this line here to use destructuring and destructure the average temperatures object here that's passed into this function. So first I'm just going to put the average temperatures variable here. And then on this side of the equal sign, I'm going to have to use the destructuring. So I'll put the curly braces, and we'll put tomorrow, and the colon, and then the other curly brace. So this is saying get the tomorrow field from the average temperatures object and assign it to the temp of tomorrow variable. So if we run this, we should see it says 79 in the console because we got the temp of tomorrow variable, we returned temp of tomorrow, and it was logged right here. So we successfully used destructuring to get the tomorrow variable out of average temperatures. We can also use destructuring assignment to assign variables from nested objects. We have this nested object right here, the local forecast, and inside we have some nested objects. So we have the forecast from today and the forecast from tomorrow. So here we have get max of tomorrow, where we're going to pass in the forecast. And here we can see the local forecast becomes the forecast variable. And we're trying to figure out the max of tomorrow. So we are going to use destructuring to figure that out. So it's going to equal forecast. And remember that is a nested object. So here, when you're destructuring, you're always going to use the curly braces. And we are first going to get tomorrow. And on the other side of the colon, we're going to have some more curly braces because it's nested. So we need to go inside of the tomorrow object, and we need the max. So we'll do max, and then we have the colon and max of tomorrow. Now we need 2 sets of squiggly braces here. So we have this one and this one. And so we've destructured two times, and the variable is max of tomorrow. So we've set the max that was inside tomorrow to max of tomorrow. So if I run this, you'll see it's 84.6. You can use destructuring assignment to assign variables from arrays. Look at this example here. So we have this array of 1, 2, 3, 4, 5, 6, and we're assigning the variables z and x to the first two numbers of the array, 1 and 2. The difference between destructuring from arrays and destructuring from objects is that you cannot specify which element from the array to go into a variable. It just goes in order. However, if we wanted number 4 to be go into a variable, we could just do like this. We would just add some commas. So we put a comma with nothing in it, like that, two commas in a row, and I'll put a y here. So now we have the first element, the second element, we skip the third element, and then we have the fourth element. So if I console.log z, x, and y, we should see 1, 2, and 4. Here's another thing you can do. You can use destructuring of arrays to switch the places of variables. Let me uncomment out these. And what I'm going to do is use destructuring to switch the places of A and B. So it'll be like this. I'll say A, B, and I'll say equals B, A. So now it's just taking this and switching the places. So instead of A being 8 and B equals 6, it's now going to log out 6 and 8. So let's see. Yep, it worked. We can use destructuring assignment with the rest operator to reassign array elements. We can see in this example, we have this array, the digits 1 through 10 in the array, and we have this remove first two function. We're calling it here, and we're passing in the source, that's the source array, and it becomes the list. So we want to return the array with the first two elements removed. So let's use the rest operator inside an array here. So we'll use the rest operator, the three little dots, and to remove the first two, I just have to put two commas here with nothing in between them. So it's saying do nothing for the first element, do nothing for the second element, everything else put into the R variable. We could have assigned the first two numbers in the array to two other variables. So I could do A, B, and then A would be 1, B would be 2, and then R would be an array of 3, 4, 5, 6, 7, 8, 9, 10. But right now, we just need to return the array with the first two elements missing. So if I run that, you'll see that we did that. If you look in the console, we've logged the array and the first two elements are missing. And then we have the original array down here. You can use the structuring assignment to pass an object as a function's parameter. Let me show you what I mean. Right now we have this half function and it's getting the stats argument. So the stats is being passed when it's called down here, and it's passing in this whole object, so this whole stats object. But you can see within this function, we're only using stats.max and stats.min. So instead of passing the entire stats into this function, we can just pass in what we need. So this is what we're going to do. I'm going to put in some curly braces here and just put max and min. So now when stats get passed in, it's destructured into just the max and min variables, and the max and min from the function gets passed in. So now instead of doing stats.max, we can just do max, and instead of stats.min, we can do min. So if we reload that, it's going to work exactly like it did before, but now we only pass in what we need. This is commonly used with API calls. When you are getting information from an AJAX request or an API request, it will often have a lot more information than what you need, and you can use destructuring to get it down to what we actually want to work with. Template literals are a special type of string that makes creating complex strings easier. You make them with this backtick. So here's an example of a template literal right here. We have the beginning backtick and we have the ending backtick. This would be in place of using a quotation, a single or double quotation mark. A few advantages of using these template literals, these backticks instead of quotation marks, are one, you can make multi-line strings. You can see this has two lines. Here's the first line and here's the second line. And if we log the greeting, it's going to put the new line right in there. Another thing is you can add quote single or double quotation marks right in the string and you don't have to escape them. The third thing is you can put variables right in the string. So if we see this, see the dollar sign, and then we have these curly braces. And so anything in between these curly braces that start with the dollar sign is JavaScript. So right now we just have this variable person.name, which gets the name from up here. And then here we have person.age, which gets the age from right there. So it makes things easier that you can put variables right in the strings. So if we run that, you'll see, hello, my name is Zodiac Hasbro. I am 56 years old. And normally it would actually also be printed with a new line, but with this exact code editor and console, it doesn't show the new line. So there's going to be a coding challenge that we're going to do right down here. We have this make list function, and we want it to create a list based on the array that's passed in. So when we call make list, we pass in result.failure. Well, here's result. Result.failure is this array here, and we want it to return an array that looks like this. Each element in the array is a template literal that has some HTML in it, and then it also has this no var on top and line break that comes right from this array that's passed in. So let's use template literals to create that. So instead of setting this to equal null, I'm going to start this off to be an empty array. Now there's many ways to do this, but I'm going to use the classic for loop. So we'll do for, and hopefully you remember how to make a for loop. We'll do let I equal 0 while I is less than r.length. And then at the end, we will increment I. So inside this for loop, we'll do result display array dot push. And then here is where I'm going to use the template literal. Put a backtick, and I'll put this HTML code here, li class equals text warning. And now this next part is going to be a variable because it changes for each array element here. So I'm going to do $sign and then the curly braces. And now I can just do R and then at index I. Now in the curly brace. And then I can just put the /li. Okay. And if we console.log this out, because we just finished that, if I do console.log result to display array, the array looks just like it's supposed to be. If you look in the console, it returns correctly.